Hello, ladies and gentlemen, welcome back to the channel. Today we're continuing our series on salvaging 1860-50 lithium batteries, and now it's time to try to charge them and analyze them in general. So what do we have there? So I'll show you what the overall process, what I'm going to follow here is. So I'm going to use my SkyRC MC3000 charger. It's a pretty good charger, lots of features, lots of things to play with. But right now what we want to do is a refresh cycle. So we'll try to charge the batteries to the full capacity or whatever it would be able to charge them, discharge completely and figuring out what the capacity is. Normally I would be using 3 volts as a cutoff. And then charge them back again. So that's the usual refresh cycle. And we'll see if we'll need to do any trickery for the cells that are completely discharged, which I can imagine most of them are. So for this charger does the instantaneous boost. So if you put the somewhat dead battery in there, it will try to push it up just for a few seconds, but if that's not sufficient, then it will refuse to charge it. But there are ways around that, and we'll see if we need to go there. We probably will. But let's see if we'll have to do it from the very beginning. So here's the plan. So I'll go for them in sequence, and I'll start from right this time around. So these batteries, NCR 18650MB. This is actually supposed to be made by Panasonic, presumably in China. Supposed to be 3400 milliamp hours, which is a lot more than most of the other cells. The rest of them are in 2024, 2500 at most. This one is supposed to be 3400, but well, we'll see about that. And all right, so let's zoom in on our charger. Well, actually, first we'll just need to put them in. All right, and it immediately shows the voltage without charging them yet. So okay, so how about we'll zoom in, because now all we need is the charger. Now we can put the all right, let's see. All right, so here's what we have. So all 3 cells have exactly the same voltage, which is great, 362. The voltage is also pretty decent, so these are not dead cells. Well, so it certainly looks that way. More than I expected, so that should be fairly straightforward to charge without any trickery. So let's just set up our program. And all right, so check voltage, because right now, well, it's actually not, can't see right now, but it used to have program number 1, which is actually charging annual batteries, so clearly very different voltage from lithium. So that's That is entirely correct. So, okay, yeah, you see, it's trying to discharge any loops, which is, these are not, and it knows it. All right, so what we'll need to do is to select different program, which would be, okay, so I have program number 3, lithium on refresh. So we'll change parameters a little bit. So this one's supposed to have 3400 capacity, and that's used to terminate the charge if it goes for too long. If it doesn't terminate via other parameters. Okay, charging current, no, we will, I think for the initial charge of all these batteries, I will go slow, probably half the amp, even though that's clearly can be charged by more than that. And this seems to be a good cell, so it should be fine, but okay, so resting periods for charging and discharging on refresh, cycle count only 1, and then that's what I meant. So charge, the cycle mode is charge, first charge to full, then discharge to, well, 3 volts, and then charge to full again. Target voltage 4.2, termination 0.5, restart. Yeah, cut voltage at 3, cut temperature at 45, and no cutoff on time. And let's save it to 3. Okay, now slot number 1 would be using program number 3, which is what we want. And it started. So slot number 2 is already using program number 3, but let's just double check. 3, 34, yeah, that's our program. It just started. And slot number 3 is also using program number 1 again, which is not correct one. So let's just change it to 3. And we started. All right, so yep, we started charging, so we can see some voltage changing, current, half an amp, and that's the capacity. Well, it's actually how much energy has been pumped into the batteries so far. We just started, so we can see some nifty charts even here. So temperature, it also monitors temperature of the cells and the system itself. So in case something starts to heat up, it will stop the process. All right, and that's basically what we would be doing for the batteries that the charger can take. And then obviously we'll see what the end result of this charge process is. And well, then we'll need to summarize that and see if we need to do anything special for the really dead batteries out there. All right, so that's going to take a while, so I'll take a break here and we'll see how it ends. See you later. All right, and our charging of the first 3 batteries, battery cells is done. Successful. I mean, that went as good as it could have. The thing is, like, during the last phase of the charge, discharge, charge cycle, so the last charge, I actually accidentally pressed the cancel button on slot number 1. So that's why you see very different numbers for that, because I just basically had to restart the last charge. But the thing is, like, all batteries tracked very all three tracked very closely together, both in terms of the voltage, timing, capacities, and so on and so forth. So it's very similar to actually cell number 2. And as you can see, the numbers actually show for 2 and 3 that these cells are in great shape. So let's just check out, let's look at cell number 2. I mean, on the overview, you can see that now we're back to 4.18, which, I mean, our termination, well, charged rate was 420, so 418, solid, no drops. It's been sitting for a few hours. Well, for the last 2 and 3, you can see charged capacities. So it's discharged capacity. So basically, these are the real numbers that the cells gave out from the fully charged to the 3 volt. And it's pretty much 3.1 milliamp hours, which is great because these cells are rated at 3400 and we've got 3100, which is a pretty much as good as it gets, considering our testing methodology is different from what they're doing to rate the cells. So for instance, we actually discharged at higher rate. We discharged at 0.85 amps. And usually for the rating purposes, they discharge at 0.2 capacity, which in this case would be a little bit less than that. And the lower the discharge rate, the higher the capacity. Also, they generally discharge to lower voltages, to something like 2.75. For the rating purposes, I discharged to 3 volts. The thing is, like, I'm not trying to replicate the rating methodology for capacities. What I want to do is to have a consistent discharge and charge methodology for all the cells, so I can mix and match. So I can see the numbers that are comparable across different cells, even though they could be from different manufacturers and so on and so forth. So from that perspective, that should work fine. So let's check cell number 2, let's say. So you can see it actually shows 2 capacities on the refresh cycle. The capacity is the discharge capacity, so the actual energy that the cell gave out. So that's not just the energy that got pumped during the charge. So, and that's 3108. Remember, the rated one is 3400. And then the charged, and that's actually the energy pumped into that on the last charge cycle from, well, almost nothing to full. And that's pretty comparable. So 3170. So all good there. Voltage 418 out of 420. Average doesn't matter. Yeah, no current charge, no power. Yeah, took 16 hours for the whole cycle. Again, I'm not in no rush. Battery temperature never went above, so right now it's basically, well, slightly above room temperature, so 23.8. It never went above about 27, 28, which is again perfect, so no heating. Yeah, system temperature 23. Internal resistance 59. And as you can see, like 58 for cell number 3. Charged capacity, or discharge capacity, almost exactly the same, with literally a few milliamp hours difference. And the first one, again, tracked exactly the same, except right now it's on a different program, which is just purely cycle charge, from where I terminated the charge component of the refresh cycle. So great results so far. These are great cells, so it seems. But again, like the next step for that would be to put them away for a week, maybe a bit more, and recheck them afterwards and see, did we have any deterioration in the voltage? I mean, we will see that. How much is that? Maybe run another cycle to see if any capacity differences are there or any parameters would be different. I mean, that would be a lot. But until then, that's basically it for the first phase, the refresh cycle. Now we'll need to see how the internal discharge is going to look like, because we don't want obviously to self-discharge rapidly, and that might be a problem with older cells, and especially the depleted cells, because these ones were relatively fine. And we'll see how it goes. So with that, I'll start moving to all the other cells that we have, and I'll show the ones that are normal, like these ones were, in terms of they didn't dip below like 3 volts charge or voltage. That would be the same process. I will post and show the end results. So I'll try to hook up this charger. Can be hooked up with the computer, so you can see some profiles on the voltage, amperage, capacitance, and so forth. Unfortunately, I haven't done it for the first batch, but I will try to do this for the rest. And I'll show one of the batches when we actually need to boost up. Sure, you can see probably. Yeah, you can see the chart for the voltage for the actual refresh cycle. So it started at 3.6, I believe. Then we fully charged it to 4.2. Then we discharged it all the way down to 3, and we charged it back again. And again, there's nothing. There was some waiting period, 30 and 60 minutes between charge and discharge cycles. Well, not cycles, but modes, I guess. And as you can see, there's nothing weird there. Yeah, again, that's just the charge for the slot number 1. Nothing weird there. Again, these kinks are because of the waiting period. Yeah, straight up looks good. And there would be more, hopefully better charts in the PC version of that. And yeah, let's see how the rest of the cells are gonna go. All right, and here is the batch of 3 other batteries. So that's Chinese BAK batteries. As you can see, that's a very different picture. So these are basically dead. 0.14, 0.09, 0.13. So, well, let's see if we can do anything with them. We have to be careful, obviously. So the initial charge for deeply discharged batteries has to be pretty slow. It's about, has to be below 0.15 amps as per most manufacturers' specifications. So I believe this charger is able to do this pre-charge, but the initial voltage needs to be in whatever 1.4, 1.5 volts range, which is clearly currently is lower than that. So let's see if we can trick it to to do that. That's, well, I don't know if it's a great idea, but let's see what happens. I mean, we'll be closely monitoring this. And there's a thermal cutoff set up as well. So let's see. Well, let's see what goes. First of all, if I'll start this program, it's basically the same refresh program as I used before, except that I changed the battery capacity cells. These cells are 2200 instead of 3400. And I'll be operating it from the computer. So let me just start it up. And as you can see, that's basically what happens when you put batteries that are too low. It says check voltage. Because while it does detect that there's something in there, it certainly doesn't feel like it's a lithium battery. All right, so let's see if we can trick it up to believe that there is actually something chargeable in there. All right, so here's something that we can try to do. So here's well, somewhat discharged lithium battery, but the one that does report quite a bit of voltage, as in 2 something volts, so we'll see in a moment. And then we can connect it in parallel to every cell that we have here, and well, that should, well, boost the voltage of the cell itself, and also will show to the charger that we have some voltage here on the terminal, and we do it fairly momentarily and see if actually charger can pick it up. As you can see, I already did a few seconds of connection on the first battery, and it's already showing above 1 volt. So I don't know how much do we need to boost it, maybe to 1.5. I don't know. So let's see what we can do about that. So right now it's basically connected, and I only need to touch the negative terminal with the negative connected to the booster cell. So see what happens. So now we have 109. If I touch it, look, it goes all the way to 2.30. And if I disconnect it, it obviously goes down again because we didn't pump a lot of energy in there. But that was probably enough to, get us some numbers. So let's see if we can do the same thing with the other ones. And you can see it goes all the way to about 2 volts, a little bit. And the same for this one. So I'm not sure if that's going to be enough. So let me try to restart. Okay, that was enough to start the first battery, which we actually did hold a little bit longer than that. So okay, let's and you can see it's doing pre-charge, so the current is 0.15, so lower than I specified, so I specified 0.5, and it will try to boost it up all the way to 3 volts. So it looks like we need to have about 2 volts here. Maybe a bit less. All right, so I think we are good, as in I managed to restart both programs, well, all 3 programs. As you can see, it's trying to load up them with 0.15 amps. And the first one is almost at 3 volts, so it should be. The other one's at 2.5. And, well, let's see how it all turns out. I'll be obviously closely monitoring this, the temperature, the parameters on the voltage and amperage. In all likelihood, it's not going to go anywhere, as in like the capacity would be very low, but I think it should be able to charge it, so we'll see. And hopefully we can see some nifty charts from the PC version of the control program. All right, see you then.